Hello, and welcome everyone to the Virtual Public Information Center for the Schedule C Class Environmental Assessment Addendum for the Newcastle Water Pollution Control Plant Capacity Re-Rating and Upgrades Project. My name is Stephanie Tran, and I work for R.V. Anderson Associates Limited, an engineering consulting firm that is part of the Regional Municipality of Durham's Environmental Assessment team for this project, and I will be narrating this presentation. I would like to take a few minutes to explain the format of this Virtual Public Information Center, or PIC. Due to the COVID-19 pandemic, this PIC is taking place virtually. This video, along with the presentation panels and script, are posted on the Region of Durham's project website. We ask that you review this video and other project information available at your leisure and provide comments back to the project team by the requested deadlines. The Region of Durham is new to virtual public meetings, and we'd like to ask for your patience and understanding as we navigate this new format. While online platforms don't allow for quite the same face-to-face interaction, please know that we greatly value your feedback and questions. We will make every effort to ensure that your voice is heard and your questions are answered. The project team will be presenting an overview of the study, including the Municipal Class Environmental Assessment Addendum process and background on the Newcastle Water Pollution Control Plant, 1991 Class Environmental Assessment, and 1992 Class Environmental Assessment Addendum. We will be presenting the study area, problem and opportunity statement, and recommended design solutions for the capacity re-rating and upgrades of the Newcastle Water Pollution Control Plant. We will also present a summary of the findings from the supporting studies recently completed for the purposes of verifying that the proposed work for the project and mitigation measures identified in the original Class EA and subsequent addendum study remains valid for the current planning context and legislation. Finally, we will present the next steps in the process and explain how to submit your questions or comments to the project team. This video, the presentation material, and the script of this presentation are posted on the Region of Durham's project website. Please submit any questions or comments to the project team at the contact information provided. Your feedback is welcome and encouraged. Please note that comments will be received until February 11th, 2022, which is 4 weeks after the release of this virtual PIC. With that, we will dive into the presentation. Before presenting the project specifics, I will take you through the Class Environmental Assessment, or Class EA, and Class EA addendum process. What is a Class EA? The Class EA is a planning process followed by municipalities in Ontario when planning for new infrastructure, which allows for public, technical agencies, and Indigenous community consultation and input. What is a Class EA addendum? A Class EA addendum is a process to revise or update a Class EA to reflect changing regulations, standards, or to include new technologies for consideration. The Class EA report is valid for 10 years, after which a Class EA addendum needs to be completed prior to commencement of project construction. Why are we doing it? This project has a long history and has been considered by the region in detail since 1991. Considering that it has been more than 10 years since the original environmental study report and subsequent Class E addendum were filed, and there is an increasing need for additional treatment capacity at the Newcastle Water Pollution Control Plant, the region initiated this Class E addendum in 2020. The main objectives of the study are to review and confirm the preferred design solutions to re-rate and upgrade the Newcastle Water Pollution Control Plant, and confirm that the project and mitigation measures remain valid given the current planning context and legislation. The Class EA addendum process is presented on this slide. There are a total of 4 steps in the study. Step A, which includes the publication of the Notice of Commencement, was initiated in June 2020 and identified the problem and opportunity statement. Step B is where we are right now. It involves completing the required background studies and confirming design solutions for the capacity re-rating and upgrades for the Newcastle Water Pollution Control Plant. The preferred solutions are being presented for feedback from the public as part of this PIC. Upcoming steps include Step C, which is to prepare a Class EA addendum report for public review, and Step D is implementation, which in this case includes design and construction of the preferred solution. The study area of this Class EA addendum is shown on the map outlined in yellow, which includes the existing Newcastle Water Pollution Control Plant and its property limits. The Newcastle Water Pollution Control Plant is located at 1000 Toronto Street in Newcastle, Ontario. The plant treats sanitary sewage from the community of Newcastle and the municipality of Clarington. It is noted that since the publication of the notice of commencement, the study area was expanded to include the proposed stormwater management concept and the Municipal of Clarington Stormwater Management Pond. Slide 8 shows the historical timeline of the Newcastle Water Pollution Control Plant. In 1991, the Region of Durham completed a Schedule C Class EA study to determine how to treat wastewater generated by the growing community of Newcastle. The study ultimately recommended that the old Graham Creek Water Pollution Control Plant that was treating the sanitary sewage for the community at that time be decommissioned, and a new plant, which is currently the Newcastle Water Pollution Control Plant, be constructed in 4 stages. Shortly after the completion of his 1991 study, the region initiated a Class EA addendum in 1992 to reevaluate the preferred treatment process alternatives and recommended that the newly proposed Newcastle Water Pollution Control Plant use a conventional activated sludge process, or CAS. In 1996, the new Newcastle Water Pollution Control Plant was constructed and commissioned with an initial capacity of 4,086 cubic meters per day. The old Graham Creek Water Pollution Control Plant was then demolished. Due to the continuing growth in the community of Newcastle, the region undertook a feasibility study in 2014 to identify upgrades required to provide additional wastewater capacity at the Newcastle Water Pollution Control Plant while ensuring compliance with effluent limits. The feasibility study confirmed that the plant capacity could be increased by completing capital upgrades and operational modifications, which will be further described in the later slides. In recent years, the growth in the community has reached a point where the capacity of the Newcastle Water Pollution Control Plant needs to be increased. Considering that it has been over 10 years since the 1991 and 1992 Class EA reports were filed, the region initiated a Class EA addendum for this work. The main objective of this Class EA addendum is to update the environmental, social, and financial settings identified in the 1991 and 1992 Class EA studies and assess and select preferred solutions for the Newcastle Water Pollution Control Plant capacity re-rating and upgrades. The Newcastle Water Pollution Control Plant uses the conventional activated sludge, or CAS, treatment process and currently operates at an average day flow, ADF, of approximately over 4,000 cubic meters per day. The treatment processes at the plant are as follows. Number 1. The raw sewage pump station receives raw sanitary sewage, also known as influent, and pumps it into the first treatment process. Number 2. The screening process removes large objects in the influent such as debris, paper, plastics, and rags to avoid damage and clogging the treatment equipment downstream. Number 3. After screening, the influent goes through the grit removal process to remove heavier and finer solids including sand, gravel, etc. Number 4. After grit removal, the influent is processed in the primary clarifier to remove floating and settleable solids. Number 5. The CAS aeration tank process is a biological process used to further treat and break down contaminants in the influent using microorganisms. Aeration tanks and blower equipment are used for the CAS process. Number 6. Ferrous chloride, a chemical compound, is added in the liquid stream in the aeration tanks to precipitate and remove phosphorus. Number 7. The CAS effluent then flows in the secondary clarifiers for further settling and separations of solids from the liquid. Number 8. Sodium hypochlorite is added in the secondary clarifier effluent for disinfection. Number 9. Sodium bisulfite is added to remove any residual sodium hypochlorite in the liquid effluent before discharging. Number 10. Lastly, the treated water, also known as effluent, is discharged into Lake Ontario. As part of the Class EA addendum process, the Environmental Assessment Team has identified the problem and opportunity statement for this project. The 1991 Class EA and 1992 Class EA addendum project objectives were reviewed, and the Class E addendum problem and opportunity statement was updated as follows. The existing Newcastle Water Pollution Control Plant requires improvements to existing services and additional sewage treatment capacity to allow for future growth for the community of Newcastle. To address these improvements, this Class C addendum will review and confirm the preferred solutions that will: Number 1. Meet the growing needs of the Newcastle community in Clarington by increasing the sewage treatment capacity of the Newcastle Water Pollution Control Plant by infrastructure optimization. Number 2. Address the plant's sustainability by using more efficient equipment. Number 3. Reevaluate process design alternatives. Number 4. Improve existing operational issues, including consideration for odor control. And number 5. Meet Ontario Water Resource Act and Environmental Protection Act for effluent discharge related parameters. In 2014, the Region of Durham completed a feasibility study to determine whether the existing Newcastle Water Pollution Control Plant could be re-rated from its current average day flow, or ADF, of approximately over 4,000 cubic meters per day and peak flow capacity of 12,300 cubic meters per day to a higher flow in order to provide additional capacity for growth and reduce the capital costs of the next expansion. The feasibility study included an evaluation of the existing plant, field investigations, bench scale testing to determine the potential for re-rating by optimizing or implementing low capital cost modifications to the existing plant. The study confirmed that the plant can be re-rated to 7,200 cubic meters per day if certain upgrades and modifications were implemented. As part of this addendum, these upgrades and modifications were further assessed, and the recommended upgrades to be carried forward for implementation have been identified. Capital upgrades from the 2014 feasibility study, which are included in this 2020 Class EA addendum, includes raw sewage pumping upgrades, screening upgrades, aeration system upgrades, outfall diffuser modification, secondary clarifier weir modifications, and disinfection system upgrades. Details of these upgrades will be reviewed in further detail as part of this PIC. Upgrades from the 2014 feasibility study, which are not recommended at this time, include construction of a sludge storage facility. These upgrades are not yet required based on the proposed rated capacity of 7,200 cubic meters per day and are recommended to be delayed for the future staged expansion. As per the recommendations of the 1991 Class EA and 1992 addendum, these upgrades should be addressed once the water pollution control plant reaches a capacity of approximately over 8,000 cubic meters per day. Sludge management will be reviewed at the next expansion. Addition of a new alkalinity system. This is not yet required for the re-rating of the water pollution control plant based on an updated review of the current water pollution control plant operations. The next few slides provide a high-level comparison of the 1991 EA and 1992 addendum recommendations and the current 2020 addendum recommendations. The table presented on slide 12 summarizes the comparison of Stage 2 water pollution control plant expansion between the 1991 and 1992 EA studies and the 2020 addendum recommendations. The 1991 and 1992 EAs recommended the construction of a new water pollution control plant that could be expanded in stages as the flow to the plant increased. At Stage 1, the new water pollution control plant was recommended to be constructed to handle an average day flow ADF of approximately over 4,000 cubic meters per day. It was also recommended for some key infrastructures be upsized to handle the future higher flows, while other infrastructure and equipment could be added or upgraded in the future. This recommendation was implemented, and the Newcastle Water Pollution Control Plant was constructed and commissioned in 1996. Currently, the Water Pollution Control Plant has an average day flow rated capacity of 4,086 cubic meters per day, which matches the Stage 1 recommendations. The 1991 and 1992 studies recommended 3 expansion stages based on the average day flow coming into the plant as follows. Stage 2, approximately over 8,000 cubic meters per day. Stage 3, approximately over 16,000 cubic meters per day. And Stage 4, approximately over 24,000 cubic meters per day. This 2020 addendum will take the Newcastle Water Pollution Control Plant to Stage 2 average day flows. However, it is recommended to reduce the Stage 2 average day flows to 7,200 cubic meters per day, as this will maximize the use of existing infrastructure. This flow is still valid with the previous recommendations and the 2014 feasibility study. It also postpones the extensive capital investment that will be required to further increase the capacity of the plant. Some smaller capital upgrades will be required as part of the Stage 2 re-rating of the Water Pollution Control Plant, which are presented in this PIC. Supporting studies to identify potential impacts and mitigation measures at the Newcastle Water Pollution Control Plant are also presented in this PIC for your review and feedback. The table presented on slide 13 summarizes the comparison of the various Stage 2 flow scenarios between the 1991 and 1992 EA studies and 2020 addendum recommendations and proposed service population. The rated capacity is the amount of wastewater that the Water Pollution Control Plant is approved to treat by the Ministry of Environment, Conservation and Parks, or MECP. The rated capacity is based on the average day flows, or ADF, experienced by the Water Pollution Control Plant. The current rated capacity of the Newcastle Water Pollution Control Plant is approximately over 4,000 cubic meters per day. Currently, the average day flow experience at the Water Pollution Control Plant is approaching the current rated capacity. As part of this addendum, it is proposed to increase or re-rate the capacity of the Water Pollution Control Plant from the Stage 1 flow of approximately over 4,000 cubic meters per day to a new Stage 2 flow of 7,200 cubic meters per day to accommodate future growth and increased wastewater flows. Wastewater treatment plants must also be able to handle peak day flows, PDFs, and peak hourly flows, PHFs, and specific processes and treatment equipment are sized to meet these conditions. The current peak day flow of the Newcastle Water Pollution Control Plant is nearing or at the limit of the capabilities of certain processes and treatment equipment. As such, it is proposed to re-rate the capacity of the Water Pollution Control Plant to approximately over 21,000 cubic meters per day for peak day flow for Stage 2. Similarly, the Water Pollution Control Plant is nearing or at the limit to handle current peak hourly flows and is proposed to re-rate the capacity to approximately over 33,000 cubic meters per day. As we look at the various capital upgrades on the next few slides, average day flow, peak day flow, or peak hourly flows will be referenced depending on the equipment or treatment process. As such, this is a change to the 1991 and 1992 Class EA studies. Supporting studies have been completed as part of the study to support the plant expansion to Stage 2 ADF expansion of 7,200 cubic meters per day and are presented in this PIC for your feedback. Lastly, based on the 2014 feasibility study, the proposed service population for Stage 2 expansion is 19,200 persons. This aligns with the potential residential and employment development as approved under the 2020 Durham Regional Official Plan and 2018 Municipal of Clarington Official Plan. Slide 14 shows the Stage 2 upgrades recommended from the 1991 and 1992 EAs in comparison to the 2020 Class EA addendum. The 1991 and 1992 EAs recommended for the Newcastle Water Pollution Control Plant's ADF to be expanded to approximately over 8,000 cubic meters per day at Stage 2. However, no specific process upgrades were recommended for the Stage 2 expansion. In addition, construction of anaerobic digestion facilities for sludge treatment upgrades were recommended. As part of the 2020 Class E addendum, it is recommended to re-rate the Newcastle Water Pollution Control Plant's ADF to 7,200 cubic meters per day. To achieve the re-rated capacity, the following upgrades are recommended to be implemented, including raw sewage pumping upgrades, screening upgrades, aeration system upgrades, effluent disinfection upgrades, and outfall modifications, including opening of existing diffusers and disconnection of stormwater sewer. It is noted that sludge treatment upgrades were not recommended as part of the Stage 2 proposed upgrades, which will be detailed further in the next slide. As such, this is a change to the 1991 and 1992 Class EA studies. Supporting studies have been completed as part of this study to support the preferred design solutions and are presented in this PIC for your feedback. As part of Stage 1, a conventional activated sludge or CAS process for treatment including on-site storage of raw sludge was constructed. The on-site storage and transfer of sludge to Port Darlington has been ongoing since the Newcastle Water Pollution Control Plant was constructed. The 1991 and 1992 studies recommended that when the capacity of the water pollution control plant will be expanded in Stage 2, an anaerobic sludge digestion facility was to be constructed. Since the design flow for Stage 2 is being reduced and the current sludge volumes are lower than projected in 1991 and 1992 reports, the transition to an anaerobic sludge digestion facility is not yet required. This 2020 addendum recommends postponing the construction of a sludge storage facility and maintaining the existing CAS process until the next expansion. This aligns with the 1991 and 1992 EA recommendations, as sludge production has not yet reached the level that would trigger the need for this facility. As part of the Class EA addendum process, supporting studies were undertaken to support the review of the preferred design solutions, identify potential impacts and mitigation measures, and verify the project and existing conditions are valid for current planning context and legislations. Studies included an archaeological assessment, a cultural heritage assessment, a natural environmental impact assessment, and a geotechnical investigation. The results of these studies are presented in the upcoming slides. The 2020 Stage 1 Archaeological Assessment was completed to update the 1992 Archaeological Assessment. The findings determined that the study area does not have archaeological potential. Therefore, a Stage 2 Archaeological Assessment field investigation is not required for the Class EA addendum. The 2020 Cultural Heritage Assessment concluded that one built heritage resource, a commemorative feature, was identified within the study area. Mitigation measures include planning construction activities and staging to avoid impacts to the identified built heritage resource and employing measures such as landscaping, buffering, installation of fencing, and issuing instructions during construction to protect, avoid impacts, and working around the cultural heritage resource. Post-construction rehabilitation will be required to return the existing public pathway to pre-construction conditions. Site natural heritage requirements are governed by the Ontario Endangered Species Act, ESA, and the Species at Risk, SARS Act. The 2020 Natural Environmental Assessment findings indicated that mature trees are present within the study area that may provide habitat for bats, birds, and SARS species. Butternut trees are also present outside the study area along the plant's fence line. Breeding birds protected under the Migratory Birds Convention Act, or MBCA, were identified to use the habitat in the study area. Timing windows will be required during the construction for any vegetation removals to protect breeding bird species. Setback of a minimum of 50 meters to restrict activities around each individual tree is required. The study area is adjacent to significant natural areas and local water bodies. Development of an erosion and sediment control plan and spills prevention plan to prevent overland sediment, latent sheet flow, and or contaminants into these areas. Fish SARS including American eel, lake sturgeon, and deep water sculpin may be present in the aquatic study area. The lake bed in proximity to the outfall diffusers did not demonstrate characteristics of high-quality fish habitat or features that support the most sensitive life cycle processes, e.g. spawning, rearing young. Potential impacts to fish habitat and necessary approvals to be further considered during design. For any species affected, mitigative or remedial measures will be implemented in the study area. A 2020 Stage 1 Environmental Site Assessment, ESA, was completed and found 4 potentially contaminating activities that were identified as low environmental risk within the study area. A Phase 2 ESA will be conducted to characterize the subsurface soil and groundwater conditions and assess where contaminants may be present. This work is currently ongoing and will be completed during design. The evaluation of design alternatives and selection of the preferred design solutions are completed as part of the 2020 addendum for the following recommended capital upgrades. Number 1, raw sewage pumping upgrades. Number 2, screening upgrades. Number 3, aeration system upgrades. Number 4, effluent disinfection upgrades. And number 5, outfall modifications. A summary of the evaluation and preferred design solutions are presented in the next slides. The 1991 and 1992 EEAs recommended that the raw sewage pumping station be sized to accommodate 4 pumps. 2 pumps were recommended to handle pumping raw sewage up to a peak day flow of approximately over 12,000 cubic meters per day. It was also anticipated that 2 additional pumps would be added and 1 pump replaced as the future flows for the water pollution control plant increased. Currently, the water pollution control plant has 4 pumps installed. 2 additional pumps were installed since 1996 to meet the flow increases over time. This is because the pumps now need to meet the peak hourly flow instead of the peak day flow, requiring a higher overall pumping capacity. The current peak hourly flow is approximately over 24,000 cubic meters per day, which matches the total pump capacity available if all 4 pumps were available. However, the peak hourly flow must be met by the firm capacity of the pumps instead. The firm capacity refers to the total capacity of all the pumps available, assuming the largest pump is out of service. In this case, the firm capacity is approximately over 18,000 cubic meters per day, which does not meet the current peak hourly flow. In addition, these pumps are at the end of their service life, are in poor condition, have operational issues including excess vibration, cavitation, accumulation of grease, clogging by wet wipes, and are undersized for its current operations. As such, these pumps should be replaced for future operation. Due to this, it is recommended that these pumps be upgraded or replaced to meet the re-rated peak hourly flow of approximately over 33,000 cubic meters per day. The upgrade or replacement of these raw sewage pumps is a new consideration from the 1991 and 1992 EA. The 2 raw sewage pump design alternatives are presented in this PIC for your feedback. This includes Alternative A, replacement of existing raw sewage pumps with higher capacity pumps, and Alternative B, installation of new sewage pumps with higher capacity in a new building. Alternative A is a replacement of the 4 existing raw sewage pumps with higher capacity pumps to achieve firm capacity equal to the proposed re-rated peak hourly flow, PHF, of approximately over 33,000 cubic meters per day. Installation of the raw sewage pumps will be staged to allow for the sewage pumping to remain operational while each pump is being replaced. Odor control technologies will be reviewed and incorporated as part of the design of this alternative. Key advantages for Alternative A include a smaller footprint is required as the raw sewage pumps will be installed within the existing building. However, it is also noted that the space in the existing building for future upgrades may be limited. Lower capital and operational costs as construction is kept within the existing building. Lower electricity requirements as the new pumps will be more energy efficient. Greenhouse gas emissions from new pumps is anticipated to be lower than existing pumps and minimizes construction works and odor issues to nearby residents. Key disadvantages for Alternative A include higher construction complexity due to the need to keep the raw sewage pumping online while the new pumps are being installed. New pumping capacity will require an MECP approvals update. Alternative B is the installation of new sewage pumps with higher capacity in a new building. This alternative recommends construction of a building expansion or new building to house new higher capacity raw sewage pumps. The new pumps will work in conjunction with the existing pumps to achieve the proposed re-rated peak hourly flow of 33,800 cubic meters per day. Odor control technologies will be reviewed and incorporated as part of the design of this alternative. Key advantages for Alternative B include minimal impact to existing sewage pumping while new pumps are installed in the new building. Expansion of the building could be sized to accommodate future upgrades of the raw sewage pumps and/or preliminary treatment processes. Key disadvantages for Alternative B include existing pumps which are in poor condition and have operational issues would remain online. Higher capital costs and complexity associated with constructing a new building or extension to house the new pumps. Expansion of building will require a new building permit, and new pumping capacity will require an MECP approvals update. Based on the advantages and disadvantages, the preferred design alternative for the raw sewage pump upgrade is Alternative A, to replace the existing raw sewage pumps with higher capacity raw sewage pumps rated at the proposed re-rated peak hourly flow (PHF) of 33,800 cubic meters per day. The 1991 and 1992 EAs recommended 3 screen channels for the installation of 1 mechanical screen to treat up to a peak day flow of approximately over 22,000 cubic meters per day, 1 bar screen for bypass when the main screens need to be taken offline for maintenance, repair, etc., and 1 spare channel for installation of future mechanical screen to expand the water pollution control plant capacity beyond the peak day flow of approximately over 22,000 cubic meters per day. Currently, 1 mechanical screen and 1 bar screen are installed. The current capacity of the mechanical screen is limited to a peak hourly flow of approximately over 28,000 cubic meters per day. The screen can meet the peak day flow of approximately over 13,000 cubic meters per day. However, it is nearing its capacity for treating the peak hourly flow of approximately over 24,000 cubic meters per day. Due to this, 2 alternatives are identified. For Alternative A, 1 new screen would be installed in the spare screen channel. This is in line with the 1991 and 1992 EA recommendations. Alternatively, for Alternative B, the spare screen channel could be modified to accommodate a larger screen, leaving the current screen channel as spare for the future. With each alternative, the screens are proposed to meet a re-rated peak hourly flow of approximately over 33,000 cubic meters per day. The alternatives for the screens are presented in this PIC for your feedback. Alternative A is the addition of a new screen to the existing spare channel. This alternative involves installation of 1 additional screen into the existing spare channel to provide the proposed re-rated peak hourly flow capacity of 33,800 cubic meters per day. Installation of the new screen in the existing spare channel will not impact existing screening process. Odor control technologies will be reviewed and incorporated as part of the design of this alternative. Key advantages for Alternative A include optimization of existing infrastructure and existing screen. The purpose of the existing spare channel was designed to allow for future expansion. Addition of new screen provides redundancy and flexibility. This allows for the screen to be taken offline for maintenance and repairs. Lower capital and operational costs. Minimal construction risks as construction is kept within the existing building. Minimizes construction works and odor issues to nearby residents. Key disadvantages for Alternative A include increased operational complexity and maintenance requirements due to the addition of a screen, no additional future capacity for the screening system. New screening capacity will require an approvals update. Alternative B involves expansion of the existing spare channel to house new higher capacity screens, installation of new screen, and making the current duty channel the standby channel. The new screens will achieve the proposed re-rated peak hourly flow of 33,800 cubic meters per day. The current duty channel will become the standby channel to provide additional future capacity for a future expansion. Odor control technologies will be reviewed and incorporated as part of the design of this alternative. Key advantages for Alternative B include provides additional future capacity for a future expansion and reduces system complexity by only having 1 operational screen. Key disadvantages for Alternative B include expansion of spare channel will require major structural modifications, higher construction risks due to major construction within existing infrastructure, and proximity to existing sewage channels in a classified area. Higher capital costs and complexity associated with spare channel extension to house the new screens. Limited space within the existing building, as expansion of the spare channel may impact future upgrades to other preliminary treatment processes. Expansion of the spare channel will require a new building permit, and the new screening capacity will require an MECP approvals update. Based on the advantages and disadvantages, the preferred screening modification design alternative is Alternative A, to install one new additional screen into existing spare channel to provide the proposed re-rated peak hourly flow capacity of 33,800 cubic meters per day. The new screen will also provide redundancy and flexibility in the screening process. It is noted that the upgrades for the preferred design alternative will be completed within the existing building. In addition, odor control technologies will be reviewed and incorporated as part of the design of the screening upgrades. The 1991 and 1992 EAs recommended 3 blowers be installed to supply air to the aeration tanks. 2 of these blowers would be duty units, while 1 would be a standby unit. The blowers were recommended to meet an average day flow for the water pollution control plant of approximately over 4,000 cubic meters per day. No upgrades to the blowers were specifically identified as the water pollution control plant expanded or aged. Currently, the 3 blowers are installed as per the 1991 and 1992 recommendations. The firm air supply capacity meets the current air supply demands to treat the overall average day flow of approximately over 4,000 cubic meters per day for the water pollution control plant. However, with the re-rating of the plant to an average day flow of 7,200 cubic meters per day, the air supply demand cannot be met by the current blowers. Additionally, the blowers are reaching the end of their service life. Based on this, 2 alternatives have been evaluated, including Alternative A, replace existing blowers with higher capacity blowers, and Alternative B, installation of new blowers with higher capacity in a new building. As the upgrade and/or replacement of the blowers were not considered as part of the 1991 and 1992 EAs, these options are presented in this PIC for your feedback. Alternative A is a replacement of existing blowers with higher capacity blowers re-rated for the air supply requirements at the proposed re-rated peak hourly flow, PHF, of approximately over 33,000 cubic meters per day. Installation of blowers will be staged to allow for the aeration system to remain operational while each blower is replaced. Key advantages for Alternative A include: a smaller footprint is required as the blowers will be installed within the existing building. However, it is also noted that the space in the existing building for future upgrades may be limited. Lower capital and operational upgrades as construction is kept within the existing building. Lower electricity requirements as the new pumps will be more energy efficient. Greenhouse gas emissions from new blowers is anticipated to be lower than the existing blowers. Minimizes construction works and odor issues to nearby residents. Key disadvantages for Alternative A include: high construction complexity due to need to keep the blowers online while new blowers are installed. New blower capacity will require an approvals update. Alternative B is the installation of new blowers with higher capacity in a new building. This alternative recommends the construction of a new building expansion or new building to house new higher capacity blowers. The new blower will work in conjunction with the existing blowers to achieve the proposed re-rated PHF of approximately over 33,000 cubic meters per day. Key advantages for Alternative B include: minimal impact to existing blowers while new blowers are installed in the new building. Expansion of building could be sized to accommodate future upgrades of the blowers and/or preliminary treatment processes. Key disadvantages for Alternative B include: existing blowers are at the end of their useful service life and require replacement. Higher capital costs and complexity associated with constructing a new building or extension to house the new blowers. Expansion of building will require a new building permit, and new blower capacity will require an approvals update. Based on the advantages and disadvantages, the preferred design alternative for the new blowers upgrades is Alternative A, to replace the existing aeration blowers with new aeration blowers rated at the proposed re-rated peak hourly flow, PHF, of approximately over 33,000 cubic meters per day. New blowers will provide the increased aeration capacity required for the re-rated plant capacity. Weirs are included in water and wastewater treatment plants to control the water levels and flows through the plant. They are intended to be adjustable to accommodate changing conditions and avoid the need for major capital upgrades. Under the re-rated peak hourly flows of approximately over 33,000 cubic meters per day, the upstream primary clarifier distribution chamber weir may be submerged. However, upstream processes are not impacted, so no mitigation measures are required. The secondary clarifier weirs may be submerged. Openings along the launders of the secondary clarifiers may need to be expanded or additional openings added. The launders are channels constructed along the outer edge of the secondary clarifier to collect the secondary effluent and convey flow to the treatment process downstream. The chlorine contact tank outlet weir may be submerged. The weir level should be adjusted so that it will not be submerged under the re-rated flow. The 1991 and 1992 EAs recommended a chlorination system be used for the disinfection of the effluent or treated water from the Newcastle Water Pollution Control Plant. This included a chlorine dosing system and a chlorine contact tank, or CCT, sized for an average day flow of approximately over 8,000 cubic meters per day. No upgrades were considered as the water pollution control plant aged or expanded beyond the average day flow of approximately over 8,000 cubic meters per day. The chlorine disinfection system was installed as part of the 1996 water pollution control plant as recommended. The existing CCT can provide the required contact time for disinfection at the proposed re-rated capacity of 7,200 cubic meters per day. However, it will not meet the contact time required under a peak hourly flow of approximately over 33,000 cubic meters per day. Additionally, the existing CCT does not meet current design guidelines for volume and dimension ratios, has reached the end of its service life, is in poor condition, and has operational and maintenance issues including insufficient mixing in the chlorine contact tank. The existing chlorine dosing system is sufficient for current and re-rated flows, while the existing dechlorination dosing system does not meet design guidelines for pump capacity and storage volume. Overall, chemical systems are at the end of their useful service life, are deteriorated, and require significant maintenance. Based on this, it is recommended that the effluent disinfection system be upgraded or replaced to meet the re-rated peak hourly flow of approximately over 33,000 cubic meters per day. As the upgrade or replacement of the effluent disinfection system is a new consideration, these options are presented in the next slide for your feedback. Alternative A is the upgrade of the existing chlorination system to treat up to the proposed re-rated peak hourly flow, PHF, of approximately over 33,000 cubic meters per day. Upgrades will be staged to allow the chlorination system to remain operational. Key advantages for Alternative A include familiarity with the chlorination treatment system, lower capital costs to construct the new chlorination contact tank and associated chemical equipment. However, higher operational costs associated with chemical usage and regular maintenance. Key disadvantages for Alternative A include increased operational complexity and maintenance requirements as multiple chemical systems will be required. Chlorinated water may cause the formation of trihalomethanes and other disinfection byproducts. High health and safety concerns due to storage, handling, and transportation of chemicals. Trucking of chemicals are required. Chlorination systems must adhere to stringent federal chlorine residual limits. New chlorine disinfection capacity will require an approvals update. Alternative B is a replacement of the existing chlorination system with ultraviolet UV disinfection treatment systems to treat up to the proposed re-rated peak hourly flow, PHF, of approximately over 33,000 cubic meters per day. The UV disinfection system uses UV light to disinfect and inactivate viruses and pathogens in the effluent water prior to discharging into Lake Ontario. The design of the system will comply with the Environmental Protection Act for effluent discharge related parameters. Key advantages for Alternative B include simple to operate and easy to maintain on a regular basis. A self-cleaning system and operator access to the system will be provided. Lower health and safety concerns for operators, as safeguards will be provided. Reduced truck traffic, as chemical delivery is not required. No formation of disinfection byproducts, which ensures safety to the aquatic environment. Key disadvantages for Alternative B include UV treatment will be a new treatment process at the plant. Plant operators will require formal training to operate the UV treatment system. Higher capital costs associated with the installation of the UV disinfection and associated prefabricated building. Lower operational costs to operate the UV disinfection system. UV disinfection treatment system and capacity will require a building permit and an approvals update. Based on the advantages and disadvantages, the preferred design alternative for the effluent disinfection upgrades is Alternative B, to replace the existing chlorination system with ultraviolet UV disinfection treatment system to treat up to the proposed re-rated peak hourly flow (PHF) of approximately over 33,000 cubic meters per day. The final capital upgrades recommended to support the re-rating of the water pollution control plant are related to the existing outfall. The 1991 and 1992 EAs recommended a 600 mm diameter outfall be constructed for an effluent or treated water peak flow of approximately over 24,000 cubic meters per day. The outfall was recommended to have diffusers which could be opened to increase the capacity gradually as the overall water pollution control plant capacity increased. Once the capacity of the water pollution control plant was beyond the capacity of the 600 mm outfall, it was recommended that the outfall then be replaced with a 900 mm outfall. The existing outfall is 600 mm in diameter and currently has 12 of 20 diffusers open, and the remaining 8 diffusers are still closed. The existing outfall with 12 open diffusers can accommodate a maximum flow of approximately over 33,000 cubic meters per day. Part of the capacity of the existing outfall is taken up by a storm sewer connection from which storm water is captured on the Newcastle Water Pollution Control Plant site is discharged to. This storm sewer connection decreases the overall capacity of the outfall available for the effluent of the water pollution control plant to a peak hourly flow of 25,000 cubic meters per day. The proposed peak hourly flow of the re-rated water pollution control plant is approximately over 33,000 cubic meters per day, which is greater than the current outfall capacity. Therefore, upgrades or modifications are required. The alternative solution are presented in this PIC for your feedback and include opening diffusers and modifying the stormwater connection or replacing the existing outfall with a 900 mm diameter outfall. While the opening of the diffusers on the 600 mm outfall and potential increase from a 600 mm outfall to a 900 mm outfall are in line with the recommendations from the 1991 and 1992 EAs, rerouting the stormwater sewer connection from the outfall is a new consideration. As such, these alternatives are presented in this PIC along with the supporting studies for your feedback. Alternative A is the replacement of the existing outfall with higher capacity outfall. This alternative recommends replacing existing outfall with a larger outfall that will provide a higher outfall capacity to accommodate for future growth beyond the Stage 2 expansion in the Newcastle community. Key advantages for Alternative A include increased outfall capacity will accommodate for future growth beyond Stage 2. Existing stormwater pipe can remain connected to the outfall. Key disadvantages for Alternative A include extensive approvals and additional studies will be required to confirm feasibility of the new outfall construction. This upgrade will be a major change to the existing outfall and will require further studies to be completed as part of the Class EA addendum. This may prolong the project schedule. Higher capital costs associated with construction of the new outfall. Higher construction risk and complexity associated with the construction of the new outfall may have potential impacts related to the aquatic habitat in Lake Ontario. New outfall capacity will require permits and approvals update. Alternative B is opening the existing diffusers and disconnect stormwater connection. This alternative recommends modification to the existing outfall, including opening of diffusers to increase the outfall capacity for the re-rated peak hourly flow (PHF) planned capacity of approximately over 33,000 cubic meters per day. The existing stormwater sewer currently connected to the outfall will also be disconnected and stormwater will be captured on site. This will optimize the existing outfall capacity and improve water quality discharging in Lake Ontario. Key advantages for Alternative B include optimization of existing infrastructure and less complex. Existing outfall will remain fully operational during construction, no disruptions to the plant operation. Disconnecting the existing storm sewer from the existing outfall will eliminate contribution to the outfall capacity. This allows to reclaim and optimize the existing outfall capacity and improve effluent water quality discharged in Lake Ontario. Storm water will be managed and treated on site via Low Impact Development (LID) prior to discharge into the Municipal of Clarington's existing stormwater management pond. Lower capital costs, as construction are within the existing outfall infrastructure. Minimizes construction works and odor issues to nearby residents. Opening of diffusers will not require new building permit and approvals update. Key disadvantages for Alternative B include does not accommodate for future growth beyond Stage 2. Construction will temporarily impact a portion of the adjacent public waterfront trail. Any disturbances to the trail will be reconstructed. Based on the advantages and disadvantages, the preferred design alternative for the outfall modifications and upgrades is Alternative B, to open existing outfall diffusers and reroute the existing stormwater sewer. Opening of the diffusers will provide additional outfall capacity for the re-rated peak hourly flow (PHF) plant capacity of approximately over 33,000 cubic meters per day. It is noted that there will be no major changes and/or modifications to the existing outfall. The design for the outfall upgrades will comply with the Environmental Protection Act for effluent discharge related parameters. As part of the Class EA addendum, the project team has developed a list of potential concerns or impacts that may arise from these works and have developed mitigation strategies to address them. A list of potential concerns and mitigations are shown in the following table. For concerns related to construction noise, traffic, and dust, proper traffic control measures will be required and enforced as part of the construction contract. Construction times will be limited to weekdays during working hours. Finally, construction fencing will be employed to control silt, erosion, and dust. These measures will be monitored and additional measures will be implemented as needed. For concerns regarding species at risk, construction will avoid disturbing the butternut trees found adjacent to the study area. Additional studies will be conducted during design to confirm potential impacts to aquatic species at risk and implement mitigation measures. Where vegetation removals are required, timing windows will be required to protect breeding birds and other species. For concerns regarding excess material management, excess construction soil from construction activities will be properly stored, reused, and/or disposed of per Environmental Protection Act. Waste generated from construction will also be disposed of in accordance with ministry's requirements. For concerns related to planning and policy, the proposed upgrades to the Newcastle Water Pollution Control Plant were verified to adhere to the planning policies to accommodate for growth in the Newcastle community while protecting Ontario's natural heritage and water resources. For concerns related to source water protection, it is noted that the Newcastle Water Pollution Control Plant is located within the Source Water Protection Area, or Intake Protection Zone, to the Newcastle Water Supply System. Existing and future mitigations, including providing an emergency response plan and backup effluent disinfection in case of disinfection failure. For concerns related to ecosystem protection and restoration, if removal of vegetation is required, new vegetation will also be replanted nearby or adjacent to the area. Timing windows to remove vegetation will be avoided during construction to protect breeding birds protected under the Migratory Bird Convention Act, or MBCA. For concerns related to climate change, a setback of 15 meters clearance will be maintained from the 100-year Lake Ontario flood line during construction. Sediment and erosion control will also be implemented to mitigate impacts on nearby water bodies and aquatic life. For concerns related to cultural heritage and archaeological impacts, the cultural heritage feature found in the study area will be avoided during construction, and mitigation measures will be implemented to protect the resource. No archaeological potential is present on the site. For concerns regarding stormwater management, mitigation measures include disconnection of the existing stormwater sewer and treatment on-site prior to discharging into Lake Ontario. Stormwater management design will be developed and implemented as per Ganaraska Region Conservation Authority, GRCA, and Municipal Clarington requirements. For concerns related to groundwater and surface water, a hydrogeological study is currently ongoing to address any groundwater monitoring requirements during construction and future operation of the facility, and to properly assess construction dewatering requirements. Stormwater will be managed and treated on site and directed to an existing stormwater management pond prior to discharge into Lake Ontario. Effluent discharge will be treated to comply with Environmental Protection Act effluent discharge related parameters. Additional concerns and mitigation measures from public comment and ongoing background investigations will be incorporated into the EA Addendum report. As a summary, Slide 33 presents the recommendations from the 2020 Class EA Addendum. The recommended re-rated capacity of the Newcastle Water Pollution Control Plant for Stage 2 includes an average day flow of 7,200 cubic meters per day, a peak day flow of 21,600 cubic meters per day, and a peak hourly flow of 33,800 cubic meters per day. To support the re-rating of the Newcastle Water Pollution Control Plant, the following upgrades are recommended. Replacement of the existing raw sewage pumps with new higher capacity pumps. Installation of a new mechanical screen in the spare screen channel. Replacement of the existing blowers with new higher capacity blowers. Existing chlorine disinfection system to a new UV disinfection system. Weir adjustments and launder modifications as needed. Reroute the existing stormwater sewer from the outfall and manage stormwater on site prior to discharge into the existing stormwater management pond before ultimately discharging into Lake Ontario. Open the remaining 8 diffusers on the outfall so that all 20 diffusers are open. Following this PIC, the next steps for the project team will be to, number 1, review and consider public input and comments received after this PIC. Number 2, prepare the Class Environmental Assessment Project File Report summarizing the entire study results. Number 3, issue a notice of study completion and publish the project file report on the public records for a final public review period for 30 days. Number 4, finally, review any further comments from the community during the 30-day review period and complete the Class Environmental Assessment process. Once the Class EA Addendum process has been completed, the Region of Durham will work on the detailed design of the various upgrades and modifications to support the re-rating of the Water Pollution Control Plant. Construction of the upgrades will then follow. If you have any questions or comments for the project team, please reach out to the project team members by email or phone. A reminder that the PIC material, including the presentations and transcripts, can be found on the project website at durham.ca Newcastle WPCP. Previous information on the project can also be found here as well. In terms of the anticipated timeline, we ask that any comments or questions about this PIC and the material presented be submitted to the project team by February 11th, 2022, which is 4 weeks from when this virtual PIC was posted online. We anticipate that the Notice of Study Completion and the Project File Report will be available for your review in late 2022. Thank you for taking the time to attend this PIC. We appreciate your involvement and feedback on this important project and encourage you to reach out to the project team by contacting us by email or phone. Best wishes, and we hope to hear from you soon.